Okay, so that's all that was. It's an RC2? No, there's an ARC1. Okay. We're getting into multi-threading. Don't change the lines below. Forbid unused imports, or remove unused import. Okay, but we don't want to change that, right? To do, define shared numbers by using ARC. Okay, so let me read this part here. In this exercise, we're given a vec of U32 called numbers with values ranging from 0 to 99. We would like to use this set of numbers within 8 different threads simultaneously. Each thread is going to get the sum of every 8th value with an offset. Okay. Each thread should own a reference counting pointer to the vector of numbers, but RC isn't thread safe, therefore we need to use ARC. Don't get distracted by how threads respond to join. We will practice that later in exercises about threads. All right, so all we need to do, we can see here, we have numbers. We want to create a shared numbers by using ARC. So that's, I think they're just looking for ARC new numbers here, right? And now shared numbers is an ARC of the numbers from 0 to 99. And then we come down here and we want child numbers to be ARC of a shared ARC clone of shared numbers to make a copy of it. But it doesn't like my syntax, so I must be getting something wrong. Should it just be an ampersand? And now it's saying can't find child number. Let me save it and see what the error is. No, that's it. That's it. So all we're doing here is creating a reference count that's shareable across threads. Each thread gets its own clone of that reference. So it has access to it, read-only access to this number, this array. If we wanted to be able to modify that list, it would have to be mutable and it would also need a mutex. Since this is read-only, everything's good. So we're good. And all the tests pass. Well, I assume they do. It just prints the numbers, but it doesn't check them. So I don't know. I think we're good. What's next? Cow1. Okay. This exercise explores the cow, clone on right smart pointer. It can enclose and provide immutable access to borrowed data and clone the data lazily when the mutation or ownership is required. The type is designed to work with general borrowed data via the borrow trait. All right, so our to-do here says replace the to-do with cow owned or cow borrowed. Oh, okay, so we have to say, what is it? We have to look at the code and say, is this a borrowed or owned value? So input here, this looks like it's owned to me because we're not changing. Well, abs_all, let's take a look at what abs_all does. It does modify the input. Oh, here's the key, right? Okay, I get it now. So abs_all does modify the input, but only if any of the values in the input are negative. Because these are all positive values, we don't actually modify any of the inputs. So that means it remains owned, it remains borrowed and not, it doesn't switch to being owned. So this should be cow borrowed. Right? We can also pass vec without ampersand, so cow owns it directly. In this case, no mutation occurs, and thus also no clone, but the result is still owned because it was never borrowed or mutated. So this would be cow owned. Of course, this is also the case that the mutation does occur. In this case, it to mute in the abs call function returns a reference to the same data as before. So it's still owned. It never switches from owned to borrowed, but it can switch from borrowed to owned. Oh, colon, right. Oh, oops. Oh, it has to have the little underscore thing in there. Okay. There we go. So that worked. What's next? Threads 1. Okay, we're getting back into threads. This program spawns multiple threads that each run for at least 250 milliseconds. And each thread returns how much time they took to complete. The program should wait until all spawned threads have finished and should collect the return values into a vector. Okay, so we have the handles in this vector here, and we should just be able to say handle, results.push handle.join. It should do it all, right? It should never hit this line because we wait for every single one. Oh, they're all results, so we would actually have to unwrap them. There. All right, next after threads 1 is threads 2. Building on the last exercise, we want all of the threads to complete their work, but this time the spawned threads need to be in charge of updating a shared value, jobStatus.jobsDone. Okay, so we've already made it an arc. We've already cloned it. But the problem is that we need to make it a mutex. So that we can lock it. So we say in here, mutex, new. Standard sync mutex. And then we can say lock. Do I have to say like as mute? What can I do here? Unwrap. Do I have to do that, or can I just do this? No, definitely we have to unwrap it. And then fix this down here. So this would be status shared. Oh, just status lock, unwrap. And then dot jobs done. Still no. U32 can't. Oh, so we don't need the star. It's automatically derefed. Okay. All right, that's good. So you have to lock it and unwrap it because the lock could fail. And then this is automatically a mutable reference. Yeah. All right. How's that? Next, we have threads 3. To do, we want to send TX to both threads, but currently it's moved into the first thread. How could you solve this problem? Gafa says, could this be done with arc get mute? It's got the mutex in there. Oh, are you saying so we don't need to do the lock if we get rid of the mutex? Let's try it. And instead of doing a lock, like this. Get mute only works when no strong references exist to the data. Yeah, so you'd have, if there was some other thread accessing it mutably at the same time, you wouldn't be able to get it, right? You'd have to spin here. Because I bet you this returns an option. Yeah, it does. And you might get a none back. Right. So I think so you'd have to say while get mute is none, spin, and then, but then you'd still have to have it, right? You wouldn't, you'd be relying on another thread not coming in for the brief time that you had it. So there's still, yeah, I don't think there's a way around that problem. So your question is, how would beginners know to use mutex? I think you're supposed to use Rustlings along with the book, the Rust book. So as you're going through the Rust book, you read the chapter on threads, and then you do the threads parts of it. So it's, yeah, I agree that it's missing some context. But I don't know that there's a way around that unless you did a couple of Rustlings on mutex things. But maybe this would be a good area to enhance the way Rustlings work. Add like a threads 1.5 that introduces the concept of mutexes and say, oh, you have to call lock on this, blah, blah, blah. And then threads 2 comes along and says, okay, now using your knowledge, how do you fix this code to work right? Yeah, JP says no one would be able to access today, even with spinning, because I agree. You need the mutex here. You need the mutex here. I don't think there's a way around that. Okay, we're still working on this one, right? Yeah. Okay, so we want to send the TX to both threads, but currently it's moved into the first thread. Right, so it's moved here, and then we tried to use it here, and actually Clippy is suggesting how to fix it. So we could say let mut value equals value, first tx is equal tx, send val. That doesn't make any sense. I don't understand this here. I think what we want to just do is tx clone, right? I think that might be a bug in Clippy. And then we can say first tx, right? So we clone it and we use it here, and then we can use it here. Oh, it doesn't need to be mutable. So there you go. I mean, I'm not sure what Clippy was thinking, because it doesn't make sense to use val before you define it, right? I'm very confused. I wonder if there's a simpler test case that we can use to file a bug against Clippy. But the reason this works is we're creating a clone of TX. TXs are clonable. And then we move that in here. We got the move keyword that moves the variable in. And then later on, we can use it in this thread. So it gets moved here. If we tried to use it a third time, it wouldn't work. If I did another thread spawn. This shouldn't compile either. Because we're using TX again, we would have to make another clone of it, like we did there. Yep. Okay, good. Okay, next is macros 1.